WIP on the DX Killer dipole. This is my 40 and 80 switch dipole. There's another video that mentions it. This is a closer up view of the feed point and the cords coming down along the transmission line that go out to, you might be able to see the little canister out there to a switch that opens and closes the switch for 40 and 80. This antenna was raised, and through this video I'm going to pause and restart to save some time here. This antenna was raised from this tree up at about that height over to this dead tree up to that height, and that brought the SWR, resuming at another position, that brought the SWR down to 1-to-1 across the entire 40 meter amateur band. Unheard of. When it rains a lot or it gets dry, very dry, the SWR will increase slightly. Here's a little closer up view of one of the switch canisters going over to this tree, which is about yay high. The antenna is probably 25 feet maybe at the center, probably 30, 35 something at the ends. And the ground slopes downhill. And there's a big metal shed roof over here. But the point is that this antenna, once I've raised this far end, or the near end, it has gone from waiting with everyone else in a DX pileup to absolutely obliterating pileups. Over the past few months, when there's any DX at all, there's a pileup, I call once, they answer me, we're done. It's almost boring. It is a major improvement in DX. My last week and a half, I've got 2 pages just full of DX contacts. This antenna just works better than the typical ham station with an amplifier and a Yagi, because they're constantly saying, "Ma, you got a strong signal." My signal with 170 watts peak in this dipole is usually on par or better than, over the past 5 years, 400 watts. Excuse me, 400 watts and hex beam or better, including Yagis, and they just can't believe it. Well, there's a reason for it, and that reason is exact tuning. I'm going to pause here and go inside and show you some excerpts from the Bible, in my opinion, on antennas, which is radio antenna engineering. Okay, sorry for the sudden cut there, but back in the ham shack, looking at the Bible on antennas called Radio Antenna Engineering by Laporte, 1952. This is the Bible on antennas, and this is page 238, section about dipoles. We notice for low power applications, the conductor size will be determined by mechanical considerations. Dipoles are not tuned just by length. But the critical thing here, well, there are 2, and I'll show you the graphs. But if you recall the myth that the higher the antenna is, the better, well, yeah, that's a myth. It's what is referred to as BS. Notice the myth is never explained, just the idea that more is better, and we can get away with a simple rationalization. This is complex physics. There's nothing simple about any of this. But on this page is a graph of height above Earth in wavelengths and dipole radiation resistance. My dipole here is fed by 75 ohm LMR 400. It's a direct burial type. Don't buy that. The adhesive, the sealant inside that coax is a nightmare to work with. Just seal up the ends well. But we see that on this graph, at about 2/10 or a quarter of a wavelength above Earth, the antenna is 50 ohms? No, it's 75 some ohms. Somewhere between 70 and 90. Look at the half wave. I often hear people with dipoles at a half wave up. boasting about their 60-foot high dipole. Okay, that is a 75 ohm antenna, and they're feeding it with 50 ohm line. Gross mismatch cannot be fixed. It's screwed up permanently. There's no height above about 0.19 wavelength that is suitable to feed with 50 ohm coax, and that's why people's dipoles don't work with a tinker's cuss. See where the impedance is, or the resistance is tending to normalize out at about 75 ohms. Dipoles, the classical engineering equation, are 73J48 plus J48. See that at about 0.35 wavelength is almost 100 ohms. So the ideal here is about 0.2 to a quarter wavelength. And realize this myth about the higher the better is a myth because of the fact that the signals we're picking up are coming down from above if we operate on a theory of atmospheric skip and reflection, which is also false. See my video on the NVIS myth. It's not atmospheric reflection, it's atmospheric ducting. But here's the other critical point. To get, this is page 234, to get the best pattern from the dipole, it must be about a half wave. See the H equals 0.50 lambda. Lambda means wavelength. You get two nice, roughly 45-degree lobes. A little bit lower, it starts going a bit more towards horizontal. My dipole here would be somewhere around the maybe a quarter wave. Not so much distribution upwards, but mostly this way. And everybody, for the most part, I want to talk to is this way, because I want skip, so to speak. But when we follow this mythical rule that that the antenna must be as high as possible, see what happens to the pattern? The dipole turns into a cloud warmer, wastes a bunch of power, in fact wastes most of its power upwards. So much for the myth. And to get back to a couple of nice lobes going at useful angles, by the way, similar to verticals, has to be one wavelength, which go higher yet starts wasting a bunch of power upwards. Now the question of what's the best takeoff angle is variable and difficult to nail down. But I'm telling you, this dipole here just absolutely destroys pile-ups. And the reason is twofold: because it is correctly tuned, flat 1-to-1 for maximum power transfer, the correct height off the ground with the correct feed line for maximum power transfer, and a nice distribution like this, roughly, I don't know, 30, 40, 50 degrees upwards. It's going up into the atmosphere. There ain't no ground wave on 40. Ground wave is for low frequency broadcasting. But there is the secret to why this dipole works so well. And again, it just flat out embarrasses Yagis and amplifiers. And as to the myth of fantastic Yagi performance, see the Radio Magazine Radio Antenna Handbook from the 1930s, where in another video I mentioned that they say there's no such thing as a tuner in the shack. Well, they also poo-poo the idea that Yagis are so fantastic. They say they refer to fantastic claims of performance, which they doubt, probably being more due to proper tuning. It's can be easier to tune a Yagi. It's a smaller antenna. Tuning a dipole can be a real problem, because that necessitates having pulleys and such to be able to lift the ends up and down and trying to get the antenna flat, which is difficult. But if I'm running almost twice the power here from the A through the Drake, which is 3 dB, and another 2 dB on a properly tuned dipole with total forward power transfer, that's 5 dB. That's Yagi performance. So there's some hints on how to put up a proper dipole. KBYP out.